Hey, algebra, we're going to be working on section 9.2, which is solving quadratic equations. Okay, so if we're looking at these quadratic equations, we have to ask ourselves, first of all, what is a quadratic? Well, the quadratic and a polynomial are the same thing. They're any type of equation that has an x squared in it. So like x squared plus 2x plus 5 would be a quadratic equation. X squared equals 4 is also a quadratic equation. It just means anything with a squared variable. All right. So, if we're moving on to these problems, we have to ask ourselves, how do we solve them? Well, we have x squared equals 4. And the way we solve that is we would take the square root of both sides. Now, here's something where we got to get a little tricky. The square root of x squared actually has to be the absolute value of x. And the reason why is because when you square something, that means it can be positive or negative. So when you get rid of a squared, you have to do absolute value. And we're going to be left with the square root of 2. Now, in order to get rid of the absolute value, that means the number inside has to be positive. Well, because that number has to be positive, the number itself can be positive or negative. So we flip it and say plus or minus 2. And we check this by plugging it back into the equation. Okay? We go 2 squared equals 4. That's correct. And we go negative 2 squared equals 4. That's correct. So we checked it, and we got our answer. Over here on the right, we do the square root of both sides. We then get the absolute value of y is equal to square root of 9 is 3. So we get y is equal to plus or minus 3. We check it by going 3 squared equals 9. That's true. And then we go negative 3 squared equals 9. That's also true. So we check it, and we're done. One on the bottom left here, we got the square root. Oop, I need to quit hitting that button. Square root again. Well, the absolute value of z is going to be, now here's a problem. The square root of 6 is not a perfect square. We don't want to do decimals, so we leave it as the square root of 6. And we go z is equal to plus and minus the square root of 6. Now the check here would be a lot simpler because we just go the square root of 6 squared. Now, the square root and squared are the complete opposite of each other, meaning if you square root and then square something, it makes the square root go away, and we're left with 6. And then over here, we have negative the square root of 6 squared. Same thing, the squared and square root go opposite each other, and the negative would become a positive because it's squaring. So there's 6. Done. Last one, we square root both sides. And we get the absolute value of c is equal to, square root of a negative number means no solution. So there you go. Those are all the cases of what the problems can look like. Now, as we get more difficult, we have to do a little bit before we can do the square root symbol. So here, we have to get rid of that negative 48 first, so we add it to both sides. So we get 3x squared is equal to 48. Now we got to get rid of the 3, so we divide by 3. So we get x squared is equal to 16. Now we can square root both sides. So we get absolute value of x is equal to 4. And this is the step you have to include. X equals plus and minus 4. The check, okay, we end up getting 3 times, and I'm just going to write 16 because 4 squared is 16, minus 48 is equal to 0. And that's true. And this one would be the same thing because negative 4 would also be 16. So there's our check, and we're all done. Second one here, we add 72 to both sides. So we get 2x squared is equal to 72. We divide by 2. X squared is equal to 36. Now we're going to move it up here. Now I do the square root of both sides. Absolute value of x is equal to 6. X equals plus or minus 6. Our check is 2 times 36 because positive and negative 6 will be squared will be 36. Minus 72 is equal to 0. And that's good. Okay. I'm going to have you try these. Okay, so we're back. We'll move through these rather quickly here. We subtract 10. 6x squared is equal to 54. We divide by 6. X squared equals 9. Square root of both sides. So x equals plus or minus 3. And then you should have checked your answer over here. But that's correct. This one down here, we had 100. 3x squared is equal to 243. Divide by 3. X squared equals 81. Square root. Absolute value of x equals 9. And so x equals plus or minus 9. If you have questions on these, bring them to class tomorrow. And there's your check. Okay? Last one. The following object model here is what we call the h equals negative 16 t squared plus s. H is the current height. T is time. And the s is not named very well, but it is initial height, okay, or starting. Okay, so you need to write this down in your notes. Falling object model. We use it quite a bit in quadratics. So, we're doing an egg drop lab, where an egg is dropped from a table that is 32 feet off the ground. The goal for the egg is to not break when it collides. How long would it take for an egg to hit the ground if you ignored wind resistance? So, the how long means that our t is what we're trying to find. Our starting height, our initial height is going to be 32 feet, and our ending height is going to be 0 feet. So now we just plug it into the equation and solve. So we get 0 equals negative 16 t squared plus 32. So from here, we're going to subtract the 32 from both sides. We get negative 32 is equal to negative 16 t squared. We divide by the negative 16. And so we get 2 equals t squared. Now we can solve using the square roots. And therefore our answer is t equals, whoops, that's not what I wanted. T equals plus or minus the square root of 2. Now, we have to think about, in this problem, is there such a thing as a negative time? Well, no. Doesn't make any sense. Just a sec, I have to call. There's no such thing as negative time in this type of problem. So we can ignore the negative. And because we're dealing with a real-life problem, we want a decimal answer. Meaning, we dropped our egg, and it will take us about 1.4 seconds for that egg to hit the ground, ignoring wind resistance. Okay, so there's an application of why you would have to be able to solve a problem like this. Okay? Here's the problems. We're going to be doing these in class tomorrow. So do not do these until class tomorrow. Okay?